All right, guys, quick review from what we were doing right before we left for break. Estimating a population proportion, confidence intervals. Remember, we're doing confidence intervals. It's been a long time. Let's review them here for a few minutes. Work on it again tomorrow. Make sure you still got it. All right, a confidence interval is a range or an interval of values used to estimate the true value of a population parameter. A confidence interval, sometimes known as CI, confidence interval. Interpreting one. You got to be careful how you say this. There's a correct interpretation. If this is my confidence interval right there, and it's a 95% confidence interval, what I could say is we are 95% confident that the interval from 0.828 to 0.872 actually does contain the true value of the true P, the population proportion P. 95% confident that it's in that interval. Finding one. You got to find Z-crit. That's a big deal. Finding Z-crit for 95 confidence interval. In here would be 95% of the data, which means 10% is split up. Sorry, 5% is split up on the outside, which means 2.5% is over here. 2.5% over here, which is really 0.025. So basically to find Z-crit, you take half of what's left. This is called alpha, so 1 minus alpha. And or alpha is 1 minus that, 1 minus 0.95, and you get 0.025, and you would take your calculator, go inverse norm, and find your Z-score, Z-crit. Okay, these are the common values we saw the most. 90%, this was always a Z-crit. 95%, that was always a Z-crit. 99%, that was always the Z-crit. Margin of error is what we need to find our confidence interval. And the margin of error, we did this right here. We did Z-crit times P hat times Q hat over N inside a square root. That's also called the maximum error of estimate, and this is for proportions. Make sure you get that as for proportions. Tomorrow we're going to start working on, the next day we're going to start working on population means, and it'll be a little bit different. All right, just a quick review of what all the letters stand for. P with no hat is population proportion, P hat sample proportion, N is how many sample values there were, E, big E, margin of error, and Z crit, the area to the right of alpha over 2 in the right tail. All right, here's a quick example. So Pew Center Research poll of 1,007, that's N, randomly selected adults show that 85%, that's P hat. Know what Twitter is. The sample results are N is 1,007 and P hat is 0.85, which means Q hat is 0.15. All right, find the margin of error, part A, find the margin of error. So I'm going to say E equals, I'm going to find my Z-crit first. And remember the Z-crit for 95% on the last slide was 1.96, so let's go in there. 1.96 times the square root of P hat, 0.85, Q hat, 0.15, over N, 1,007. So I'm going to punch that in real quick, or I hope it's real quick. My calculator here, I got 0.85 times 0.15, that about 1,007. Boom. I got 0.022 for my margin of error. So that's part A. Part B, find the confidence interval. So to find a confidence interval, all you do is you take your P hat, which is 0.85. I'm going to do P hat plus or minus my 0.022 to find my confidence interval. So I'm going to do 0.85 minus 0.022 and get 0.828. And then I'm going to do 0.85 plus the 0.022 and get 0.872. So that is my confidence interval right there. And then part C, based on the results, can we safely conclude that more than 75% of adults know what Twitter is? Yes, we can, because I am 95% confident that the true P, the true population proportion, is between 83 and 87%. So I'm pretty sure I can conclude that more than 75% of adults do know what Twitter is pretty safely. Okay, sample size. To find out how big a sample you need, 2 ways to do this. If you know P hat, we're going to do it this way. That should look familiar. And it's the same formula we just did. We just solved it for M. If you do not know P hat, what we're going to do is we're going to put 0.25 in place of my P hat and Q hat and work it out that way. Everything else is exactly the same. Let's try one and we'll be done. All right. Many companies are interested in knowing the percentage of adults who buy clothing online. How many adults must be surveyed in order to be 95% confident that the sample percentage is in error by no more than 3 percentage points? Part A, part A, they're telling you that P hat is 0.66 because that's the recent survey we got. from the Census Bureau. So I'm going N equals Z crit, which is 95% again, so it's 1.96 again. Yeah, that's my Z crit. It's squared times my P hat, which is 0.66, times my Q hat, which is 0.34, over my margin of error squared. Now the margin of error they told me is 3 percentage points. Don't forget to change it to a decimal first before you square it. And we got a bunch of stuff to punch in my calculator. So I'm going 1.96 squared times 0.66 times 0.34. All that divided by 0.03 squared. My sample size is, this comes out 957.8, but remember we always run up to the next whole number, so 958 looks good. Part B says, assume we do not have any info from the Census Bureau. So to find the sample size in that case, still use 1.96, but because I don't know P hat and Q hat, you always substitute 0.25 in its place. The bottom's still the same, still 0.03 squared. Just gonna punch that in just like last time, 1.96 squared times 0.25 divided by 0.03 squared, and I got 1067.11, so you round that up to 1068. Okay, so tomorrow in class we're going to spend one more day doing what we did right before we left for break, to make sure you have that, mainly because what we're doing as we go on is very similar to it. So you need to know the proportion stuff so you can do the mean stuff the next couple of days. So I'll see you then. See you, bye.